Today we're going to look at how we can boost the efficiency and performance of our animation blueprints using the multi-threading features built into Unreal Engine. So this is a copy of the default Mani animation blueprint, and later on we'll look at how it changes in Lyra. But as you can see, everything is being done on the BlueprintUpdate animation function. And the way that this works is that it will be executed in sequence on the game thread. At the same time, the game thread must execute in sequence all the event graphs on the actor blueprints, on AI logic, input, and so on. And as long as these functions are simple, things might move smoothly. However, if it hits a bottleneck where you come across a complex or computationally intensive function, you will then get slowdowns. So this particular function here changes the pose of the character so that it is looking at a particular target and scaling its head accordingly. And if I open that, you can see that it is a function with loops going through over 2,500 indices, making calculations so that it can work out the pose target, look at location, and the head scale vector. And that will all be run in sequence, not only on this animation blueprint, but on any other animation blueprint that is running on another character at the same time. So let's look and see what happens to the frame rate. When I press play, you can see that we get a widget saying multi-threading off. And on the left, we've got the current frames, the lowest frames per second, highest, and the average frames per second. And we're just running this on one character. And what it's doing is every tick and every frame, it's calculating which way the spine has to bend to look at the target actor, which are these yellow balls when they're selected, and the head scale as a consequence. And as you can see, the frames per second are now down to about 41 frames. If I press T, it will now turn the multi-threading on. And as you can see, the frames per second have now gone from about 40 up to 55. And that's at the same time as I'm recording this at 60 frames per second. So we're getting closer to the smooth 60 frames per second that we'd want in our games. And that's because we are now using multi-threading. If I turn it back off again, you'll notice when we do the running around that actually when I'm doing it, it feels a little bit sluggish and slight perceptible drop in responsiveness. Again, with the physics, it's working, but it might not be as smooth. If I turn it back on again, I find that the animations are a lot smoother, the key inputs are a lot more responsive, and the physics are smooth as well. And now we're up to about close to 60 frames per second with multi-threading, versus when it's off, when we drop down to 41. So there's an almost nearly 50% increase at the extremes. And that's with just one character running the animation blueprint. If I add a second character to the scene, you can now see that as both of these are running the same animation blueprint, frames per second are now on average dropping to 36, 35, and even lower. If I turn multi-threading back on again, we'll now see that the frames per second are now going back up to 54, 55, or even and around that sort of range. So again, there is an almost close to 50% increase in frame rate with the multi-threading turned on, even for multiple characters versus just one. And the animations remain smooth, and the input is smooth as well. If I turn it back off again, we drop down to about less than 30 frames per second, and there is a certain sluggishness that returns. The characters are a little bit less responsive on the input. The reason for that is that with the multi-threading turned on, instead of having to execute all of this animation blueprint on the game thread, it can be now pushed off to worker threads, and each of those worker threads can be executed simultaneously in parallel. thereby removing some of that bottleneck that you would otherwise have on the game thread. And that ensures that both the animations, the physics, all remain smooth in your game. And you can get close to 60 frames per second. As I said earlier, this multi-threading is already enabled in Unreal Engine. So if you go to your project settings and just type in multi-threaded, you will come to the Anim Blueprints Allow Multithreaded Animation Update, which is on by default in the current version and the previous versions. Also, if you go to your animation blueprint and you go to the class settings, you will see that under Optimisation, Use Multithreaded Animation is on by default. And as it will say, this allows the Anim Blueprint to update its native update, blend tree, montages, and asset players on a worker thread. And the compiler will attempt to pick up any issues. So that means that we can use it by default. However, there are some caveats with multi-threading relating to root motion. So if you go to your class defaults and you have a look, whenever you are using root motion, either from everything or from montages only, while that root motion is being played out, you will lose multi-threading. By the same token, I think when the montage is playing, it will switch from worker threads back to game threads. And the reason for that comes down to the fact that in root motion, you are changing the transform of the character, so that has to be synchronized on the game thread. However, whenever it's doing something else, like calculating the pose or all of these calculations, and not doing the root motion stuff, you will still benefit from multi-threading. All of this is still being taken place on the game thread, so it happens in sequence. And the game thread cannot just create a worker thread because it is hitting a bottleneck in a function. So if you want to turn all of this into a multi-threaded approach, how do you do that? Well, in essence, you need to override a function that is available in the animation blueprint, and it's called this, the BlueprintThreadSafeAnimationUpdate animation. And on that animation update, this will all be executed on a worker thread. So like it says, executed when the blueprint is updated on a worker thread. And from here, you can then call functions, which are also thread safe functions. And these functions will be executed in sequence on a worker thread instead of on sequence on a game thread. So for instance, I've created a thread safe version of the other function that we saw, and it's identical in all the calculations it performs, but it is marked as a thread safe function, which means it can be called on that blueprint thread safe update animation and executed on a worker thread. This function, which we saw earlier, which was causing the bottleneck, is not a thread safe function. So this can only be run on the game thread. However, turning a non-thread safe function into a thread safe function is not simply a case of clicking the box. So if I click that box and press compile, you'll see we get a lot of errors. And those errors will say that we are accessing references or calling functions that are not thread safe. Whereas in our thread safe function, we overcome that problem by using what are known as property access nodes. And that is how we can turn a function into a thread safe function. So let's look at how property access nodes, thread safe update animations, and thread safe functions work. If we go to a copy of the animation blueprint that comes by default with the third-person template, we'll see, as I said, that everything is run on the game thread. And as we went through earlier, all this logic is updated every tick, one after the other in sequence, which can cause a bottleneck. Whereas if you can move your logic into the BlueprintThreadSafeAnimation animation, it can be run in parallel for multiple animation BPs simultaneously, and that can remove the overhead on the game thread where the bottleneck was occurring. So if we want to turn this into a worker thread function with the aim of having nothing working on the update animation unless it is absolutely necessary, the first thing we need to do is to override that function. So the BlueprintThreadSafeAnimation animation. And this can be run on a worker thread and call in sequence other functions that are thread safe. So once you update it, you can either put logic directly into this graph, or you can create functions that it can call. But those functions must be thread safe functions. So if we look at here what we need to do, we want to put all of this into a thread safe function. So we could just copy it all. There, Control C, and maybe make a new function, and we'll call it thread safe update movement variables. And the first thing we need to do is to mark that as being thread safe. Now, if I was to just paste everything that we'd copied directly in here and maybe try to, with a sequence, hook it up and starting off here, you'll notice it will start to get errors. So the movement component gives us an error that says it is not a thread safe. So accessing an object reference is not thread safe, and that causes a fatal issue. So what is the issue here? Essentially, like I've written in this comment, is that thread safe functions cannot directly access non-thread safe blueprints or components. And in order to do so, you need to use this property access feature to read their data and call their functions. And the way that you use a property access is if you right click and you scroll down by typing property access, you will end up with this property access variable option. So how does the property access feature work? The issue with thread safe functions is that they cannot directly access data because the game thread could be trying to access it at the same time, and that could cause issues or crashes. So what the property access system here does is that it copies the data automatically when it is safe to do so. And we use this property access node to then reference variables or components and data that exists in other blueprints or objects. And that is why this fails, because we cannot directly access data using this. So as we cannot directly access the variable, we need to use the property access system, which will automatically access that variable and copy the data when it is safe to do so. And when you click down on a property access node like this, you'll notice that you get access to a group of functions here and to properties here. These properties correspond to the ones that you have defined in your animation blueprint. And these are functions which are being provided by Unreal in the animation blueprint, essentially by default. So you can access delta seconds, the owning actors, and the try get pawn owner, which is the main one. From that try get pawn owner, we can look for get velocity. So we can just type it in, go across, and now we have the get velocity function, which returns the velocity. So I can click on that. And now this variable here, we can try to use instead of this. So we could delete this and plug this in here using the property access feature. As you can see, this now compiles okay, because it will copy the data from the pawn owner's velocity, and we can then set it as a variable in our animation blueprint. The same way we would need to try and do this. So we got the movement component getting the current acceleration. So we can get another property access node. Bring this up here. We can go down. We've also, on our initialize blueprint, created a reference to our character. From our character, we could look for our get character movement component. So that's here. And from there, we should be able to find get current acceleration. And as you can see, you can get the current acceleration or you can get the individual properties. We want the get current acceleration. So this will get an access to the character reference, to its movement component, and call this function on it in a thread-safe manner. So we can then put that into here, delete these two, and what would have otherwise caused an error should now compile OK again. We can do the same thing to get the is falling, because as it stands, we will get an error. So again, get movement component, object reference is not thread safe. We cannot directly access this. So we get another property access node. And we want to, from the try get pawn owner, we can actually just go across movement component and look for is falling. So all of these functions which we can access from the property access node are all considered thread safe. And if something is not thread safe, it will not appear on here. So you can trust the functions here. And this we can just put into that set. We can delete both of these, and that should compile perfectly fine. So now we've created a update function that is thread safe, and we've used property access nodes in order to reference the variables or the functions in a thread safe manner. So this should not result in any crashes. And if we go back to our Blueprint Thread Safe update animation, we can now call that. So all of the functions you call on this update animation which execute on a worker thread must be thread safe. And these functions, if we had another function or another function after it, they would all execute in sequence, but they would execute on a worker thread in parallel rather than on the game thread. And if we had multiple animation blueprints all running the same blueprint, they would all try to use a worker thread for every tick update as it became available. The property access system does a lot of the work for you to make things thread safe for multi-threading. It also has a lot of functions available here, which you can call in your thread safe functions. These are all provided to you, but you can create your own functions. So for instance, if I wanted to create a function that compared the actor's rotation to the control rotation and returned a delta rotator after doing the calculation, and I wanted it accessible here, we can do that. And the way you do it is you create a function. So we could just say this is our thread safe delta rotator. You mark that as being thread safe, and you also mark it as being pure because you want a result to be returned to you. From a function, you can have a return value. So a return node. And if I wanted to do that calculation, I could get a property access. I could look for the try get pawn owner and look for the actor's rotation. I could get another property access. Again, from the try get pawn owner, this time I could get the control rotation. I could do a delta rotator. and then I can return the value here. And the key with this return value is that it must be named exactly return value. Nothing else will work, and you can only have one return value. So this is Threadsafe pure, and the output is called return value. If I went back to the Blueprint thread safe, now I could, for instance, when I go in the drop-down, I get access to that function, delta rotator, or I can get access to the individual properties within it. And I could now use that in a Threadsafe function, or I can use it here. So for instance, I can't do a print string because print string is not thread safe. I could do a log string and pop that in there, and that would compile perfectly fine. The other thing you notice is that in this particular case it says thread safe, so access made on a worker thread. There are options to change the call site, so you can have automatic, thread safe, game thread pre-event, post-event, and so on. And as you notice in one of our, here for instance, when we are getting the current acceleration, it's doing it on the pre-event graph. It is normally best to just leave it as automatic, and Unreal will decide based on the context and the thread safety where it needs to make that call. You do have options to change it, but if you, for instance, try to override it to thread safe, it will give a warning and it will go back to doing the pre-event graph. So again, it's often best to leave it at automatic, but just know that you could, for instance, maybe do game thread post-event, and that would be okay, but thread safe would not. So I'd almost certainly leave most of them on automatic, and it will make that determination based on the context and the property. So when we go back to our event graph now, basically we can delete everything that we were doing on the game thread, because all of this has now been executed on our BlueprintThreadSafe function. And this should be the aim when you're making your animation blueprints, is that there should be almost nothing on the update animation so that you do not get any performance bottlenecks on the game thread. And they are being done on the Threadsafe update so they can run in parallel for multiple animation BPs simultaneously. This, on the other hand, is probably not such a big issue because it just happens once. However, we, for instance, no longer need this reference. We can keep the character as that's just done one time only. And now our BlueprintThreadSafe function, update animation, is now doing all the work on a worker thread. So in terms of these property access nodes, we've been using them in Threadsafe update functions, but you can also use them anywhere in the animation blueprint you need to. You can also access the property access nodes in your animation graph. So this is my animation graph. This is the control rig, and it has an alpha value. And I've created a Threadsafe function that is Threadsafe pure with a return value of an integer to decide whether it should run the control rig. So I could just access that with a property access here, go down and get the TS use control rig and plug that in there. And that will give me a value. The other way is to disconnect that, click on the control rig, go to the details, and under the alpha, there is a pin. And from there, I can get access to the property access node as well and find the function that I created. Click on that, and that too will compile perfectly fine. You can also access it in your state machines or on your transitions. So for instance here, I could do a property access and get access to the should move and put that in there. So again, that would compile perfectly fine. The other thing you might notice is that on these nodes here, there is a lightning, which says that fast path is enabled. So this node is not using any blueprint calls to update its data. And this is another optimization to speed up your animation graphs. And the way that fast path works is that internally it copies variable values instead of having to directly access them, which is slower. We go back to our class settings. We've used this, which is on by default, use multi-threaded animation. There is also a warn about blueprint usage, which will warn us whenever we are accessing data or variables with blueprint calls. So when you click on that and compile, we'll get a warning. So result uses blueprint to update its values. So if I click on that, we'll see that this is a to-falling transition, which is using blueprints, and there's no lightning here. As opposed to if I went here, on this transition, there is a lightning, meaning that fast path is enabled. So how do I get this to use the fast path enabled? Well, we can do that using property access as well. And the way that we need to do that is if you click on the result, we need to use one of these functions. So let's say we use the onUpdate, create binding. This is a Threadsafe function, so it can only do Threadsafe calls. But you can set property values like we've seen before, and as long as they exist in the animation blueprint, that seems to be safe. So we could take a copy of what we were using. So if we take this copy, go to our onUpdate, and we turn this into a property access approach. So property access, we want the velocity Z, which we've set in a Threadsafe before. So we can access that, and we can just put that in there. We can then set this value for something that can be accessed later. So we can promote that to a variable and say jump fall rule. We can plug all this together, and that should update OK. We can leave this as is falling, or we can put that as a property access as well if we wanted to. So it is falling there, or we can get it from the try get pawn owner, movement component is falling. And both of those would work. We can then go back here and we can delete this. And now we just need to get access to that new property. So we can bind there, we can go down and say jump fall rule. And when we put that in here and compile, we get the fast path enabled. So that's one way of ensuring that your transitions or anything else in the animation blueprint is fast path enabled. And that warning that we turned on here will tell us whenever we are using blueprints to update a value, because that will stop the fast path from being enabled. Or if you're doing certain calculations in the graph here, that will disable the fast path as well. So we've looked at how we can get property values from our animation blueprint, or even our owning character using property access nodes. We've also seen that we can change these values that exist on our animation blueprint, like we do here, in a Threadsafe function. And I suspect that these changes are maybe synchronized on the game thread at the end of the worker thread, so as to prevent access from both threads causing issues. The question is, though, how can we set a value on our owning character? So I have a variable on our third-person character called canSet from animation blueprint. And if I wanted to set this value from the animation blueprint, the question is, can I do it? And two, should I do it? So if we have a look to see whether we can actually do it first or not. So we'll create a function that is thread safe, ts set value on owner. And we'll mark that as being thread safe. So we can get a reference to our character, either from the character or even from the try get pawn owner. From the try get pawn owner, we can run a cast to third person this character. And then from there we can say set can set from ABP. So that's the property that we created, and mark that as true. Now if we try to compile this, we get an error saying that accessing an object reference is not thread safe. It's giving an error on the cast, but that should be possible. The issue has something to do with this. So there is a way around it, but the question is whether we should do it or not. So what we can do is we can get a safe reference to the pawn owner. So I can create another function, safe pawn reference. I can do a property access, get the pawn owner or the character, and then I can return that. This has to be a return value like we saw before, and this will be thread safe and pure. Now we compile. We go back to the other function, and we change this or remove the binding and use safe pawn reference. And now when we compile, we don't have an error anymore. And it seems that we can set this variable from this reference. The question is though, as we are doing this on a thread, on a worker thread, is it safe to make this change? Because if it was being accessed on a game thread in the character, would it crash? Or does this change get pushed to the game thread to actually take place, in which case it would be okay? As a rule, when working with thread safe functions in the animation blueprint, you don't want external characters changing values on the animation blueprint, but rather you want the property access node to go and get that value from the external actor. By the same token, we probably don't want to be changing values on that external actor in return. So a better way of doing this would probably be to just set a property on our animation blueprint, which could be monitored by the character that's interested by casting to the animation blueprint. Or when that property changes in this function, we could monitor that in our event graph and maybe do an event dispatcher to whoever was interested. So we've gone through the basics of property access nodes, blueprint, thread-safe update animations, and fast path enabled. And we've shown how we can put everything onto the blueprint safe update animation function. And as a result, we've managed to remove everything from the blueprint update animation event, which runs on the game thread. In fact, we don't even need that. As we can see, these property access nodes are very powerful. And basically, they give you access to almost all the variables or properties that you would need. So many of these are all built in, and as you start drilling through, you can get all kinds of information. Is controlled, is bot controlled, the controller, velocity, parent components, you can even get the level. So again, nearly anything that you might want access to, you can access using the property access feature. And as we showed, you can also create your own functions here so that you can access properties that are not available by default. You can create properties here like we showed, but you could actually turn all of these into functions on the property access function here. so you can remove all your properties as well. And that is probably the best thing to do. So the less properties you have, the less chance something externally can try to change it. And these functions here can be accessed by external blueprints. So the game thread can run Threadsafe functions, but not vice versa. Now that we understand how all of this works, it might be worth looking at the Lyra project to see how Unreal has utilized it. So this is an animation blueprint in the Lyra game project. And as you can see, they've written this Anim blueprint does not run any logic in its event graph, for the reasons that we gave, that it can be a performance bottleneck. And everything is on the ThreadSafeUpdate function, so that it can be run in parallel and simultaneously. If we look at their blueprint for their ThreadSafeUpdate, you can see that they have got so many different ThreadSafe functions all operating in sequence. And all of these are being called on the ThreadSafeUpdate animation function, which can be executed on a worker thread. And each one of these is in itself doing a lot of calculations. And basically, all of the functions here and all of the functions here are all Blueprint thread safe. Location data, rotation data. As you can see, there's a lot of calculations going on. And you can see that they are using a combination of properties which they're storing and property access nodes. And as all of these are on the thread safe, they'll be executed in sequence on a worker thread without causing bottlenecks on the game thread. And if multiple characters are all utilizing the same blueprint, they can all run simultaneously instead of in sequence. So I hope that explains to you how simple it is to use the multi-threaded feature that's available in the animation blueprint just by putting everything on the Threadsafe update animation function instead of the blueprint update animation, and using thread safe functions and property access nodes.